Alright, in this part we're going to review a problem on two-way table, and we're going to consider about the seating area in the football game. Okay? So suppose in the football game between Ohio and Indiana, 1,000 people were sitting in the area A in the stadium, and 703 people were from Ohio, and all the rest were from Indiana. And furthermore, we know that of the people from Ohio, 129 were females, and the rest were the male. And also in total, we know that 815 males were sitting in the area A. So in the first part, we want to construct a two-way table to represent the actual count of the corresponding category in the table. Okay? For example, just as a refresh, suppose we're considering about this box here, and this box means the actual counts of the male from Indiana. Okay, just a review. All right, let's look at the actual problem. Okay, we will start from the first sentence saying that there are 1,000 people in total sitting in the area A in the stadium. That means the total number is equal to 1,000. That means we're going to write 1,000 in this box here. That means the total amount or total count or total number. Okay? So next, we know that 703 people were from Ohio, and this 307 will be written in the box here. That means the total counts of the people from Ohio, and all the rest from Indiana. And all the rest, we can do a subtraction, that is 1,000 minus 703. The result is 297. Represent the total number of people from Indiana. Furthermore, of the people from Ohio, then remember that the total number from Ohio were 703. Of this amount of people, 129 were females. That means of all the people from Ohio, 129 were female. Okay, we're going to write 129 in this box. And next, we will be able to find the number of males from Ohio. That can be done by using 703 minus 129. If you do the calculation, the total count of males from Ohio is equal to 574. And then we know that in total there are 815 males sitting in the area A. That means the total number of males is equal to 815. And then we can do another calculation to find the number of males from Indiana. That is done by 815 minus 574, and we can see it is 241. And in the variant, we can figure out this box here, that is 1,000 minus 815 equal to 185, and then we can find the very last box by using 185 minus 129, which is given by 56. Okay, so now we already complete this two-way table. Okay, this is the result of the first part, and then let's go to the second part. And in this part, we're having the same condition, but we're going to use the probability notation. For example, PO, and here O means a person from Ohio, I means a person from Indiana, M means a male, and F means a female. Use probability notations such as PO, that is the probability of a person from Ohio, PM given O, that is the probability of male given that he comes from Ohio, or PFI, that means the probability of a female given she is from Indiana, to fill in the following table with no calculations. Okay? And firstly, we look at this first box here. This means the probability of a male from Ohio. So we are going to write P M given O. Okay? And for this box here, it is the probability of a male given that he's from Indiana. So by using our abbreviation, we can see it is equal to P of M given I. Okay? So don't care about this line before them. And next, we look at this box here. This means the probability of a female given that she's from Ohio. And so we can write it as P F given O. And for this box here, it is the probability of a female given that she is from Indiana. So this is P F given I. Okay, now we look at this box here. This means the total. We don't care about where this person comes from, either come from Ohio or Indiana, but we only care about this person is a male. So basically, this is PM. That means the probability of a male. And similarly, for this box here, this means the probability of a person is female. That means it is P of F. And then we look at this box here. And in this case, we don't care about a person whether he or she is a male or female, but we only care about this person comes from Ohio, so this is PO. And for this box here, by the similar argument, this is PI, the probability of a person from Indiana. And for this box here, we're adding either these two probabilities or these two probabilities to represent the total probability, because we're considering about the probability of all people, that is the whole sample size. So this box must have 1. Okay? So when you consider about the two-way table, this box here is special. It always have value of 1. Okay? So this is how you use probability notation to fill in this two-way table. And finally, we are going to look at this table, the same situation, to fill in the following table using actual probabilities. Okay? So again, remember for this box here, it is the probability of a male given that he is from Ohio. And for example, this box here means the probability of a female given that she's from Indiana. Okay? So by using the first part, we got the counts of each category. We can do the calculation. So let's go to the third part. So for example, for this table here, it is the probability of a male given that he's from Ohio. So remember the definition of the conditional probability, that PM given O is a person is both a male and he's from Ohio divided by the probability of a person from Ohio. Okay, so this is equal to, so remember the counts of a person is male and he's from Ohio is 574, and then divide by 1000 because we're looking at the probability, and then a the count of Ohio people is 703, then divided by 1,000. And if we simplify it, it is 574 divided by 730, and its actual value is equal to 0.3704. So we're going to fill in this box by 0.704. Okay? And this is how you find the first box. And then, for example, we want to find this box here. Okay? So it is the probability of a person that is a female and she is from Indiana. So we're going to revise it as P of F and I divided by I. And so the counts of female and Indiana is 56, and the probability is 56 divided by 1,000. And then the probability of a person from Indiana is 297, and the corresponding probability is 297 divided by 1,000. So we will have 56 divided by 297, and its value is 0.303. So we're going to fill in this box by 0.303. Okay, so we can find the this box and this box by the similar way, and I'm going to give you results directly here. That is, in this box it is 0.296, and the value of this box is 0.697. Okay, and then we look at the other 5 boxes. For this one, it represents a person from Ohio, so we can find its value by using the total number of Ohio people, that is 703, divided by the total count, that is 1,000, that is 0.703. And by a similar way, we can find the probability of a person from Indiana, that is 0.297. Okay, and for this box here, it means the probability of a person is a male, and it is 0.815. And this box here, it is the probability of a person is a female, which is 0.185. And finally, like what I said earlier, for this very last box, it is always 1. Okay? So this is how you complete this two-way table by using actual probabilities. Alright, next, let's go to the fourth part. We want to determine whether the events choose a female and choose a person from Ohio are independent or not. Okay? So, if the two events, say A and B, are independent, that means the probability of A and B is equal to the probability of A times the probability of B. And so here we can let A to be the event of choose a female, and let B be the event of choose a person from Ohio. Okay, choose a Ohio person. Alright, From the two-way table, we can see that the probability of a person from is a female is equal to 0.185, and the probability of choosing a person from Ohio is equal to 0.703, and the probability of choose a people from Ohio and this person is a female is equal to 129, that is the actual count of the females from Ohio, divided by 1,000, which is equal to 0.129. And we can see that PA and B here, which is equal to 0.129, is not equal to PA times PB, so they are not independent. Okay, so remember, if you want to determine whether two events are independent or not, you just need to look at this formula here. If they are independent, then the probability of both events will happen is equal to the product of the probability of A and the probability of B. Otherwise, they are not independent. Okay, for the last part of this problem 3, we're going to look at the probability of a person from Indiana, given that this person is male. So that means we're looking at PI given this person is male. So again, we're going to write down this expression by using the formula, that is PI given M equal to PI and M, that means a person from Indiana and this person is male, divided by the probability of this person is male. So the actual count of the people from Indiana and the people are males is equal to 241, and then its corresponding probability is 241 divided by 1,000. And the probability of males is 815 divided by 1,000, like what we found earlier. So if we simplify this expression, we have the probability of a person from Indiana, given that this person is male, is equal to 241 over 815. Okay, so this will be the final result.